Welcome students. Today we are going to see a new topic, that is chi-square test. Chi-square test has two applications. One is to test the independence. Second one is to test the goodness of it. In this class we are going to see the test of independence. The agenda for this class is to understand chi-square test of independence. Before going to the topic, let us see when will you go for chi-square test. At the beginning of the lecture, I have explained different types of data: nominal, ordinal, interval, ratio. Whenever the data is nominal or ordinal, we have to go for a test called chi-square test, because data which are nominal in nature, you cannot go for z test, you cannot go for t test or ANOVA, you can regression, it cannot be done. So now I will explain how this connection as with other test. For example, we might have seen, we have studied one sample t test. Suppose there was a sample 1 was there, we have seen with the help of x bar we have predicted mu. After that we have seen two sample t test. This is one sample z test. Whenever there is a two population 1, population 2, say this is x1 bar, this is x2 bar. Here what we have compared, what was our null hypothesis? Mu 1 equal to mu 2, H1 mu 1 not equal to mu 2. Here we are comparing two population at a time. So here what you have done, we have done two sample, we write we have done two sample z test. Similarly, we have done two sample t test also. 1, this is 2. Suppose if there are 3 population, population 1 and population 2 and population 3. Here suppose we want to compare the mean of these population, our null hypothesis will be mu 1 equal to mu 2 equal to mu 3. Alternate hypothesis is mu 1 not equal to mu 2 not equal to mu 3. Here what you have done, whenever we want to compare more than 2 population, we gone for ANOVA, right. The same way, if you say there is one sample, here we can say one sample proportion test, one sample z proportion test. Suppose if we want to compare the proportion of 2 population, we can do 2 sample z proportion test. There may be a situation where we have to compare the proportion of more than 2 sample, that time we should go for this chi-square test. Suppose if you are comparing mean where the population is more than 2, you should go for ANOVA. Suppose if you are comparing the proportion where you have to compare more than proportion of more than 2 population, you should go for chi-square test. That is the logic of using chi-square test. Even if there are 2 sample mean, instead of using 2 sample z test, you can use ANOVA also, you will get the same result. Similarly, if there are 2 sample proportions, if you want to compare their proportions, instead of using 2 sample proportion test, you can do the chi-square test also, you will get the same answer, because this ANOVA and chi-square test is in a generalized format. If you want to compare only 2, that time also you can use ANOVA. Okay. Now we will go to our topic, today's topic, that is the test of independence. This test is used to analyze the frequencies of 2 variables with multiple categories to determine whether the 2 variables are independent or not. So whenever there is a qualitative variables, whenever the data is nominal data, we should go for test of independence. Here we are going to have 2 category. Suppose this is called table, contingency table. There will be some value in the row, some value in the columns. So we are going to see whether these are dependent or independent. With the help of an example, the next slide I will explain. For example, suppose you have conducted a questionnaire. In that questionnaire, This is an example of investment examples. You are asked, in which region of the country do you reside? There was a 4 options. First option is northeast, midwest, south, west. And you have asked another question also, which type of financial investment are you most likely to make today? The option was stocks, bonds and treasury bills. This data set I have captured in the form of a table. So, this table is called contingency tables. See, in rows I have captured the geographic region, say northeast, midwest, south and west. In column I have captured what type of financial investment they are going to make. So, that I have E, F, G. Suppose I wanted to make an assumption, I wanted to test, is there any connection between, is there any dependency between the geographic regions where they reside and the type of investment they are willing to make. So, there are 2 variables, one is geographic region, another variable is type of financial investment, whether these are dependent or independent. So, this kind of examples, this kind of problems can be solved with the help of this chi-square test. Okay. So, what is here null hypothesis? The geographic regions and the type of investment which they makes are independent, there is no connection. Alternate hypothesis is it is not independent, there is a dependency. This was the theory behind this test of independence. Suppose if A and F are independent, A, F, what is A here? A means the first option, that was he belongs to northeast region, F means he is willing to invest in the bond. If A and B are independent event, we can write P of A intersection F is P of A and P of F. Then we will find out what is the P of A. P of A is your N of A divided by total N, capital N, that is number of sum of all the elements. Then P of F is N of F divided by total element. So, when you multiply intersection of P of A and F, so that will be N of A divided by N multiplied by N of F divided by N. Now, you will get here in the terms of probability, but if you want to get in terms of frequencies, so that has to be multiplied by your capital N. So, expected value of AF equal to N multiplied by PA intersection F. So, it is N. For P of A we know it is N of A by N, P of F we know it is N of F by N. So, this N get cancelled, the remaining is N of A dot N of F divided by N. So, this is very frequent formula which you are going to use. Suppose if you wanted to know this expected values in this cells, what you have to do? You have to multiply the row sum and column sum divided by your capital N. So, row sum multiplied by column sum divided by total number of elements, that will give you the expected value of each cell. One more thing, you see that we are multiplying by N here. N is because if you put P of A intersection F, you will get only probability. If you want to get the answer in terms of frequency, that has to be multiplied by your N, that is why we are getting this N. So, expected frequency is Eij is Ni, I represents row, J represents the column, Ni means the total of row I multiplied by Nj, the total of column J divided by capital N, the total of all frequencies. This is our expected frequencies. Obviously, there is one more frequency which you have to find out, the observed frequency, that will be given in the problem itself. Then how to find out the test statistics of our chi-square? So, the calculated chi-square or observed chi-square value is the sigmas of sigmas. See, first one is observed frequency FO minus expected frequency whole square divided by expected frequency. You see that the square is not for this expected frequency, it is only for the numerator. And another important thing is degrees of freedom. The degrees of freedom is row minus 1 multiplied by column minus 1. That means that many number of independent cells we can supply any values. So, R represents number of rows, C represents number of columns. We will take an example using the theory which I have taught to you so far. We will solve a problem of test of independence. Suppose before starting any hypothesis testing problem, the first step is to first write the null hypothesis. The null hypothesis is the type of gasoline is independent of income. Alternative hypothesis is type of gasoline is not independent of income. Generally, there are different type of gasolines. We have the assumption that people who are having higher income, they will go for good quality in fuel. So, we are going to test this. Is there is any connection? Is there any dependency between their level of income and the type of gasoline they prefer? This was our problem setup. So, in the rows I have captured their level of income, a level of income less than $30,000. Next category is $30,000 to $49,999. Next is $50,000 to $99,000. It is more than $100,000. In column, I have asked what type of gasoline you are using, fuel you are using, regular, premium, extra premium. Generally, there is an assumption whenever the income level is increases, the people may go for good quality fuel. So, there is a dependency, that is our assumption. There may be a dependency between their level of income and the type of fuel which they use. Here the rows, there are 4 rows, 1, 2, 3, 4, there are 3 columns. So, R equal to 4, C equal to 3. First we will find out the degrees of freedom. Assume that the alpha is 1%, the degrees of freedom is row minus 1 multiplied by column minus 1. There are 4 rows, 4 minus 1. So, 4 minus 1 is 3. There are 3 columns, 3 minus 1, 2. So, 3 into 2 it is 6. So, for 6 degrees of freedom, so the chi-square distribution is the right skewed distribution, it will be like this. So, when right side area is 1%, for 6 degrees of freedom, the value which you got from the table is 16.812. The next slide I will tell you, this value we can find out with the help of Python. This was the value which you got from the table. Next what we have to do, we have to calculate the chi-square value. If our calculated chi-square value, how we will calculate it? Using this formula. Using this formula, observed frequency minus expected frequency whole square divided by expected frequency. Using this formula, we have to find out the chi-square calculated. If that value is greater than 16.82, we will reject our null hypothesis. If it is less than 16.812, we will accept our null hypothesis. As I told you, with the help of Python, import pandas, import numpy, from scipy import stats, stats.chi2.ppf, when it is a 0.99, because if we want to know 1% it is 0.99, for 6 degrees of freedom this is 16.811, that is what the value we got it. This was the data which is given as the what is the value which is there inside the cell, it is called observed frequency. So, what is the meaning of this 85? Those who are having income less than $30,000, they have gone for a regular type of gasoline. What is the premium? What is the interpretation of this 16? Those who are having income less than $30,000, only 16 people have gone for premium type, right, this one. You see that when the level of income is increasing, you see that here also the number is, the people gone for extra premium also increasing. It seems to be there is a dependency between their level of income and type of gasoline they chose. So, this is the given data which we have captured. So, the first step is you have to find out the row total. The first row total is 107, second row total is 142, third row 73, fourth row 63. Then finding the column total. The first column total is 238, second column total is 88, third column total is 59. The value which are given is called observed frequency. Now we should go for our expected frequency. Here the expected frequency value is given in the bracket. For example, how we got this 66.15? This 66.15 is nothing but multiplication of row total 107 and the column total 238 divided by 385. So that value is nothing but 66.15, that is given in the bracket. So the values which are given in the bracket, it is called expected frequency. The value which is not in the bracket, it is called observed frequency, that is the data which are given to us. So for the second data set, how we got 24.46? So row total 107, column total 88 divided by 388. So we will get 24.46. For third one, row total 107, column total 59, the total value is 385. Like this we have to find out all the cells. All the cells after finding is was given in the bracket. Now we will go for chi-square calculated value. Now we will find out the chi-square calculated value. As we know that the formula for chi-square calculated value is observed frequency minus expected frequency divided by expected frequency. So with that you see that 85 minus 66.15 whole square divided by 66.5, this is the first cell, first row first row second cells, this 16 is our observed value, this is 24.46 is our expected value whole square divided by 24.46. So if you keep on extend this, you can go up to last cell. So when you sum it, it is coming 70.75, this is 5, this is 70.75. We know that previously we have seen that this value is 0.01, our calculated value is 70.75, it is lying on the right hand side. So we are going to reject our null hypothesis. When we reject our null hypothesis, what was the null hypothesis? The level of income and the type of fuel they choose are independent. So when you reject it, what we are concluding, there is a dependency between their level of income and the type of fuel they choose. Generally it is an assumption, when the level of income is increasing, they will go for higher quality of the fuel. That was the conclusion. The table which we had seen previously, it is called the contingency table. It is useful in situations involving multiple population proportions. It is used to classify sample observations according to two or more characteristics, also called cross classification table. The another name for contingency table is cross classification table. We will solve one example here. This is also similar to our previous problem. Now this is another example. Suppose we are going to compare the hand preference versus gender. So the dominant hand may be, for some people it may be left, some people is right. The gender is male versus female. We are going to have a hypothesis that is there any connection, is there any dependency between the gender and their dominant hand. So here are two categories for each variable. So this is called 2 cross 2 table. We examined the sample of 300 college students. This was the outcome. In the rows we have asked, are you left hand or right hand, dominant hand say left. In the column we have captured the gender, female and male. There are 300 observations. Out of 300 observations, 120 are female, 180 are male. Out of 300, 36 are left handed, 264 are right handed. So the sample result organized in a contingency table. The sample size is n. So 120 females, 20 were left handed, this one, 180 males, 24 were left handed, right. So what is our hypothesis? H naught equal to pi 1 equal to pi 2. The proportion of females who are left handed is equal to the proportion of male who are left handed. Now, dominant hand, left hand is taken as the reference. We are going to compare that left hand people with respect to their gender. So, taking left hand is the dominant hand, we are going to find out is there is connection between their hand dominance and their gender. That is a null hypothesis. The null hypothesis, proportion of female who are left handed is equal to the proportion of male who are left handed. Suppose if you accept null hypothesis, so there is no connection between their dominance of left hand and their gender. What is alternate hypothesis? The two proportions are not the same, hand preference is not independent of gender. So, what will happen if H naught is true, then the proportion of left handed females should be the same as the proportion of left handed males. So, we can say there is no dependency. The two proportions above should be the same as the proportion of left handed people overall. Instead of taking left hand as a reference, you can take the right hand also. Both result will be the same. We have seen this formula, that is a chi-square test statistics is observed frequency minus expected frequency whole square divided by expected frequency. F0 says observed frequency, Fe is expected frequency. Here there are 2 cross 2 table. So, the degrees of freedom is 2 minus 1 multiplied by 2 minus 1. So, it is 1 degrees of freedom. We assume that there is an important assumption, each cell in the contingency table has the expected frequency is at least 5. We have to make sure that the expected frequency is at least 5, that is an assumption. If it is not there, we have to collapse 2-3 columns so that to get the expected frequency is 5. The chi-square test statistics approximately follows the chi-square distribution with 1 degrees of freedom. What will happen? The decision rule is if the chi-square value is greater than this limit, we will reject it, otherwise we will accept it, otherwise we call it do not reject it. So, this is the observed frequency. Now, we have to find out the for each cell expected frequency. How we got this expected frequency is nothing but 36 multiplied by 120 divided by 300. So, how we got this one? 36 multiplied by 120 whole divided by 300. How we got this value? 36 multiplied by 180 divided by 300. The same way how we got here 264 multiplied by 120 divided by not 120 300. Here 264 multiplied by 180 divided by 300. So, we will get a value for this. The next one, we have to find out the observed frequency minus expected frequency whole square divided by expected frequency plus for this one 108 minus 105.6 whole square divided by 105.6 plus for this cell it is 24 minus 21.6 divided by 21.6 whole square, not whole square, only for the numerator, plus 156 minus 158.4 whole square divided by 158.4, that is we are getting this 0.7576. Now, we have to mark this one. So, the table value which we got, this is a chi-square calculated value, the table value which for 1 degrees of freedom, this is 3.814, our calculated value is lying on the acceptance side. So, we have to accept null hypothesis. If chi-square value is greater than 3.841, reject H naught, otherwise do not reject it. Here the chi-square value, that is 0.7576 is less than your 3.841, you do not reject H naught and conclude that there is insufficient evidence that the two proportions are different. That means that both are same, P1 equal to P2. There we have compared only two proportions. There may be a possibility we have to compare more than two proportions, for example 3 proportions. That case we will see in this problem. Extend the chi-square test to the case where with more than 2 independent populations. Say null hypothesis can be pi 1 equal to pi 2 equal to pi 3. The alternate hypothesis is not all of the proportions are equal. Thus other formulas are same. As usual, f0 is observed frequency, fe is expected frequency, chi-square is the degrees of freedom. So the formula is to number of row minus 1 multiplied by number of column minus 1. We will see one example. The sharing of patients' records is a controversial issue in healthcare. A survey of 500 respondents asked whether they objected to their record being shared by insurance companies, pharmacies and by medical researchers. The results are summarized on the following table. So there are 3 categories now. One is whether they have objected to share the data for insurance companies, pharmacies and medical researchers. So this table shows like this. So you see that 410 patients have objected to share their data with the insurance companies. 295 patients have objected to share their data with the pharmacies. 335 people have objected their data to share with the medical researchers. Now we have to find out whether the proportion of objection for sharing their data, all these 3 categories are same or not. So we can say this is pi 1, this is pi 2, this is pi 3. So null hypothesis will be pi 1 equal to pi 2 equal to pi 3. That means that the people are always object to share their data irrespective of what kind of company it is. That is our null hypothesis. There is a independency between sharing their data and the type of companies which they asked for the data. Here what I have done? I have done the row sum. This was the row sum, this was second row sum. Then I found the column sum. There are 3 columns, 3 columns. This data is our observed frequency 295, 410, 335. Next one, from the observed frequency I have to find out the expected frequency. We have already observed frequency. How will you find the expected frequency? For example, here 1040 multiplied by 500 divided by 1500. So that value it will be 346.667. Similarly, for second data set it is 1040 multiplied by 500 divided by 1500. That data is your 346. This way you can find out the expected frequency. Now I have given the final answer for the first cell, that is the observed frequency minus expected frequency whole square divided by expected frequency. For this cell it is 11.157, here it is 7.77, this is 0.392, this is 26.159, this is 17.409, this is 0.88. When you add it, that value is your 64.1196. So what is null hypothesis? As I told you, pi 1 equal to pi 2 equal to pi 3. Alternate hypothesis is all of the by j are equal, that is j 1, 2, 3, 4. Decision rules: if the calculated chi-square value is greater than your table value, reject H naught, otherwise do not reject it. The table value which we got from the table is 5.9. What is the degrees of freedom for knowing this? You see that there are 2 rows is there, so 2 minus 1, there are 3 columns is there, so 3 minus 1. So this is 1 multiplied by 2 will be 2 degrees of freedom. For 2 degrees of freedom, for given alpha value, the chi-square value which you got from the table is 5.991. But you see that our calculated value is our 64.116. So it is bigger than our table value, so we have to reject. And we can conclude that at least one proportion of the respondents who object to their records being shared is different across the 3 organization. So, what will happen when you reject a null hypothesis? We can say it is not always equal, there are somewhere it is not equal. So, not all of the bij are equals. In this lecture we started a new topic, that is a chi-square test. Chi-square test has two applications, one is test of independence and goodness of fit. Today we have started with the test of independence. I have taken a small example, I have explained with the help of example how to test the test of independence. The next class we will take one small problem, with the help of Python I will explain how to construct a contingency table. After constructing contingency table, how to do chi-square test of independence using Python, that you will see in the next class. Thank you.